All right, here's the study guide. We're going to work out the study guide problems together. Please make sure that you have a working calculator. Let's clear our calculator. Second plus 7. We're going to go over to all. Make sure everything is reset. Okay, reset everything. Second plus 7, stroll over to all and then reset. Also, make sure that you have white paper. At the top of the white paper, we are going to write our name. Mrs. Reyes. And this is our study guide, Unit 2, study guide. Okay, which means we're going to have our test very soon, okay? All right, so let's go ahead and get it crack-a-lacking. All right, this is calculator active. Let's do the very first question. The first question, it says, which value should be added to the table in order shown to prove that h of x, which is the same as saying y, okay, is a linear function. So that means this is a linear equation. If it's a linear equation, that means the slopes, or that means it's going up by the same amount every single time. So we are going to calculate the slope by choosing 2 points from the table to see how much is going up or down every single time. The points that they give you, we got one of them here. And remember, you only need 2 points to calculate the slope of the table. So we're going to use the first 2 points that are given. Okay. This is x1, y1. This is x2, y2. And again, we want to know how much is going up or down every single time. Okay. So we're going to use the slope formula, y2. I don't know why I put this on this paper. I keep forgetting that I want us to use the white paper. We have 0 on the white paper, okay, because this is what I want you to take a picture of to submit. All right, this is x1, y1. This is x2, y2. And again, we're finding the slope so that we can figure out how much how much is going up or down each time, okay, in that table. All right, so we got y2 minus y1 over x2 minus x1. So let's substitute the values in. Y2 is 10, minus is a part of the formula. Y1 is negative 4. On the bottom, x2 is 2, minus a part of the formula, x1 is 0. So on the top, minus a negative is the same as saying plus a positive, and that gives us 14. On the bottom, this gives us 2. So it's going up by 7. How do I know it's going up? It's because my answer is a positive 7. Okay? So let's look at this then. Let's look at this. So if it's going up 7, we're going to add 7 every single time. So that's negative 4. Got negative 4 plus 7, and that gives us 3. Okay? So we're going to put 3 here. So that eliminates these, doesn't it? All right, so let's check to make sure it's right. Then we add another 7 here. That gives us 10. Add 7 here. That gives us 17. This is 17. And add 7 to 24, and that gives us 31. So our answer here is C. So on your white piece of paper, write C as your answer. Okay. Number 2. Number 2 says that Erica needs a test average of 85 or higher. So it can be 85, 86, 87, 88, anything that's 85 or higher. There are 4 test items. Okay, her first 3, she made a 78, then she made an 80, then she made an 88. All right, which inequality can be used to find what the score needs to be on the 4th test? All right, so look, this is how this goes. The first 3 tests, 78 plus the 80 plus the 88, okay, plus X. These are the first 3 tests, and the last test, we don't know what it is, so we're going to put X. We're going to divide it by 4 because it's 1, 2, 3, 4 tests. Now, this average should be greater than or equal to 85 because that's what it's saying, okay? So we're going to look for that inequality. All right, so this is not it. You see how it's finding the average of the three and then adding this? You don't find the average that way. You have to add all four scores together and divide by 4. So A is not right. B is not right because it's doing the same thing A is. It's just changing the inequality. C, look, they did the same thing we did, divided by 4, but this is saying that this score right here is less than or equal to 85. No, we want to know when it's greater than. So our answer here is going to be D. Okay? So D is going to be our answer. All right. It's always a good idea to write your answer down in a different spot when you're taking a test because you want to, just in case you skip it, you can always go back to your scrap paper and look to see what your answer was without having to redo everything over again. Number 3, it says the growth rate of a tree, which growth rate is the slope. The growth rate of a tree in years per inch is also known as the growth rate, is also known as the growth factor. Factor means multiply, okay? So they're still talking about slope. The slope of the line of best fit in the scatter plot represents the growth rate or the factor of the tree. This is your line of best fit here. This is the line that is in the center of the points, okay? So now we have got to decide. Says the table below the table below lists the growth factors of the different species of trees. What species of tree is most likely represented in the scatter plot? So we need to figure out what the slope is of the scatter plot because the slopes are given here. So whichever slope is closest to the slope of the line of best fit is the tree that they're talking about. So let's figure out what the slope of the line is. So to find the slope of the line, use y2 minus y1 over x2 minus x1. And you pick 2 points on the line. So right here, we know this point is 0, 0. And now we have to pick another point that's on the line, not close to it, but has to be on it. So let's see, as I keep going up on the line, I can read this point right here. So this is the point that I want to use. 20 is x and 60 is y. So we got 20, 60. So this is x1, y1. This is x2, y2. All right, so let's substitute. Okay, so on the top, this gives me 60 minus, and I keep forgetting, Lord help me, please remember that. 0, 0, 20, 60. To write it on this paper. X1, Y1, X2, Y2. All right, so on the top, you get 60 minus, 0. And on the bottom, you get 20 minus 0. So this gives you 60 divided by 20. All right, so 60 divided by 20 is going to give us 3 or 3.0. So look at the different slopes here, and 3.0 is right here. So our answer is going to be B. Okay, our answer here is going to be B. All right, number 4. Okay. Excuse me. It says, the table below shows the height in inches and the weight in pounds for several women. This is X, this is Y. Using the line of best fit, so a linear best fit model, which is the same as line of best fit. So that means that we have to write the equation y equals mx plus b. We're doing lean reg in the calculator for this. What is the predicted approximate weight? Okay, so let's do the line of best fit in the calculator. Okay, so we already cleared the calculator. To do the line of best fit in the calculator, you go to stat and go to edit, and you type your x values under L1. So that's going to be 58, enter, 60, enter, 63, enter, 68, and 72. You can press the enter button or the down arrow to get to the next line. Press the over arrow to go to L2 to put your Y values in. So this is 115, enter, 125, enter, or press the down button, 129, 142, 155. Pause the video if you need to, if you need more time. All right, so now after you get all the points typed in, make sure it all matches up, okay? You go to Stat, you go over to Calc, and you go down to Lean Reg, okay? Go down to Lean Reg. Okay, I want to be able to see what my predicted amount is, so I'm going to have to use a function table. So in order to do that, I don't want to have to write the equation under y equals to view the function table. So I'm going to type in second 1, comma, second 2, comma, remember we go to vars, y vars, and press enter 3 times. And what that does is that puts this equation under y equals. So I can either graph it or I can look at the function table, okay? So I have my line of best fit, which is what I wanted. It says, what is the predicted? So we're going to use the line of best fit, and it says, what is the predicted approximate? That means we're estimating the weight. So we're looking for Y, okay, of a woman who is 70 inches. So X, which is the height, is 70. So what is Y when X is 70? So let's use the function table. So when we use the function table, we press second graph. That gives us a function table. But look, it's going up by ones. It will take us forever to get to where X is equal to 70. So watch what I do. Go to table set, second window, and I could either start at 70 or I can, you see where it says independent? I can go to independent and press X. And when I go to second graph, I can just type my X value in. So my X value is 70. And look at what it gives me for 70. It gives me a Y value of 148.74. Okay? So now, what is that closest to? That is closest to 149. So for number 4, X is equal to 70. And Y for that X value is 148.74. So that's about 149. What letter choice is that? That's letter B. Okay, that is letter B. All right, number 5. Number 5. The table below shows the height and the weight of 5 players. This is the height and this is the weight. 1, 2, 3, 4, 5 players. Okay, good. In the starting lineup for the basketball team. Again, it says line of best fit based on the line of best fit. So we have to find the line of best fit again, which means we're going to have to do linear regress so it can give us an equation. We're going to find the residual value. Okay, so residual is how far your actual is away from your predicted. Okay, that's what residual is. So what you do is you get your line of best fit. All the values that are on the line of best fit are your predicted. These values that they give you that they give you is the actual values. So this is always your actual. This is what's given. We are getting ready to find the predicted amounts using the line of best fit. Okay, so this is the weight, but this is going to be predicted using the line of best fit. Okay, this is using the line of best fit. So the best way to do this, I'm going to clear my calculator. Second plus 712. And I'm going to go to stat. And I'm going to find my line of best fit first. Okay? So my line of best fit. I type in my X values. Oops. 67, 70, and 71. Okay? All right. So we got that. Okay? And go over. Type in the Y values. 120, 135, 142, 160, and 167. Okay, make sure that they are right. Okay, and they are. All right, so now we're finding the line of best fit by going to stat, go over to calc, and go down to lean reg. Okay. Again, I want to be able to use the function table. So I want to press second, 1, comma, second, 2, comma, vars, and press y vars and enter 3 times. All right, so what did that do, Ms. Reyes? That put it under y equals. So I can either graph the line of best fit or I can use the function table. In this case, I need to use the function table. Why, Ms. Reyes, am I using the function table? Because I need to know what the predicted weights are for the line of best fit. These are actual, but I want to know the points that are on the line for these heights. Okay, so let's go to our function table. When we go to our function table, you see um, it'll take us a long time to get to 60 and all of these numbers. So what we're going to do, again, table set, and we're going to go to X. So this is my X, it's my Y. Never do X for dependent because that's the answer, right? You're only going to do X for X because we want to enter our X values, okay? So we got table. Let's enter our X values. So this is my actual, but let's see what the predicted is for 60. So for 60, the line of best fit says that the predicted amount would be 118.21. 118.21. Okay, let's type in 64 now. This is the actual, but the predicted is this 134.83. 134.83. Okay, the actual is this. What's the predicted? 67. Type that in. That's 147.29. Type in 70. That's 159.76. And type in 71. That is 63.91. 163, sorry, 163.91. All right, good. So these are my predicted values, okay? So now we want to know what is the residual. So to find your residual, your residual is always going to be your actual minus the predicted, okay? So what are we finding the residual for? 71. This is 71 right here. So that means you're going to say 167 minus 163.91. And that will give you your residual. Okay? So let's type that in. Oops. Sorry. This is 167 minus 163.91. And that gives us 3.09. So 3.09 is our residual. This is number 5. So your residual is 3.09. Okay. So let's read our answer choices. Let's choose the best answer. It says the predicted weight. So this is your predicted weight, is approximately about 3.1 pounds less than. And look, the predicted is not wait a minute. The predicted here is less than this actual. Do you see how it's less than? So this part is true. Okay, is less than the actual weight. So that part is very true. Okay, so far this is the best answer. The predicted is approximately, it's more, no, it's not more than the actual weight. Here, these numbers are wrong. Okay, so our best answer here is going to be A. So here for number 5, we're going to put A on our paper. And we're going to move on to number 6. Okay? All right. So number 6 says, this table shows the length of the spring varies with the mass hung from it. Okay? So this is saying, it said, what would the y-intercept be? The y-intercept is where x is equal to 0, or where the line crosses the y-axis, where line cross y-axis. Okay? All right. So here we are gonna work. Let's work backwards to figure out what was the starting length when the mass was 0. Okay, what's the starting length when the mass is 0? Go back. So we want, this is our x, this is our y. Let's look at the pattern here. What's happening is going up, but how much is it going up by? So let's do backwards. We could do 22 minus 30. And so it's going up, or we could have did the other way around, sorry. It's going up by 8. Okay, this is adding 8 every single time. So in order to figure out what it was before, my pencil is breaking. In order to figure out what it was before, we're going to say 22, write this on my paper, number 6. We got 22 minus 8. So when we do 22 minus 8, that gives us 14. So it was 14 before. So the ordered pair is 0, 14. It was 14 to start with. So the starting amount is 14. The y-intercept is 14. Intercept is 14, or B is equal to 14. Okay? Number 7. Excuse me. Number 7. A child attached a spool of string to a kite and started to fly the kite. The elapsed time, x, this is in seconds, and the length in feet, okay, that's going to be y, between the spool and the kite is shown below. All right, so here we go. How do we do this? Okay, so it's asking what information is provided by the slope. So that means we got to find the slope, okay, of a linear equation that models this this data. So let's find the slope. Let's figure out what the slope is. How much is it going up every single time? Remember, y is on the top, x is on the bottom. Or you can use y2 minus y1 over x2 minus x1. Same thing, okay? Y is on the top, x is on the bottom. So if we're using these first 2 points, this is x1, y1. This is x2, y2, okay? So number 7. We have on the top, our y2 is going to be 60. This is minus 50. So we have 60 minus 50. And on the bottom, we have 2 minus 0. So this is going to be 2 minus 0. Please rewind or pause it if you need more time, okay? So on the top, this is 10. And on the bottom, this is 2. So 10 divided by 2 is going to give you 5. So this is, remember, your y is on the top. That's the length of the string. So that's 5 feet per, and your x is seconds. Okay, so 5 feet per second. So we got 2 of them that say that. We got the kite being released at a rate. And let's see, let's make sure Child's spool started flying. The elapsed time, okay, being reeled in. Okay, so this is the release rate, okay, because it's getting further away. This is the release rate. Reeled in means it's coming, they're pulling it back in. You see these numbers are going up, so that's the release rate. If you're reeling it back in, then these numbers would go in the opposite direction because you'd be rounding the string up. So this is the best answer here, C. Okay, so the answer here is going to be C. Number 8, it says, the table shows a set of data. This is a set of data. These are your X values. These are your Y. Using the line of best fit. So we have to do line of best fit again. Write the equation. Y equals mx plus b. We're going to do that in the calculator. What can be concluded about this data? So we're talking about, let's look at the answer choices. They're talking about correlation coefficient, so we need to find that in the calculator. And we're talking about whether it's going to be negative, positive, if it's close to -1 or whatever. Is it a strong correlation? So we're going to clear our calculator again. And remember, this time I'm going to use diagnostic on so we can figure out what the correlation coefficient is. The letter for correlation coefficient is R, okay? All right, so let's clear second plus 7, 1, 2. I'm tripping. Okay, actually make sure it goes through, right? Second plus 7, 1, 2. All right, so now we're going to type our numbers in the calculator. So go to stat and go to edit. Our x values, we're going to put in L1. So that's going to be 13, 21, 38, 42, 53, and 60, 64. Okay? All right, so now let's type in our y values. Okay? So that's negative. Don't forget to use the negative sign here. Okay? The negative sign is down here. So that's negative 30.9, negative 79.5. Oops. Oh gosh. I didn't put it in the wrong. Sorry, y'all. I'm glad I did that. To show you how to go back, you just press delete on the numbers you don't want. So let's start over. This is my y values. So that's negative 30.9, then negative 79.5, then negative 107.8, then negative 152.3, then negative 190.8, and negative 227.9. All right, good deal. All of those numbers are typed in now. So now we want to go to second catalog because we need to do diagnostic on. I could have did that first, really, just to do diagnostic on. But you got to do that before you do lean reg, okay? Because you want the correlation coefficient. So diagnostic on. Don't forget to press enter. It has to say done. Then we're going to go, we already typed the numbers in. We're going to go to calc, lean reg, and all I want is the correlation coefficient. So I'm just going to press enter. I don't need to graph the line or to use the function table for this problem. So all I'm looking for is my R. So I just press enter, and my R, number 8, let's see, my R is right here. It's a negative, let's see, R is equal to a negative 0.985, okay? So what does that mean, Ms. Reyes? That means it's a negative correlation, okay? And it also means that it's very strong, okay? It's very strong. All right, so let's look at our answer choices and let's choose the best one. Okay, so A, since the correlation coefficient is a negative, there is not a strong, that's not true, okay? Just because it's negative, that don't mean it's not a strong linear. It could be a strong negative linear correlation. Since the correlation is a positive, and it's not, so we know that's not right. Since the correlation is closest to -1, and it is closest to -1, there is a strong negative linear relationship. This is true. Okay? So our answer choice for 8 is C. So I'm going to put C there and move on to number 9. Okay? Number 9. It says the graph below shows the number of compact discs and the number of packs of batteries sold in a certain store each day during 1 week period. Okay, notice how it's going up. Okay, it's curving up. Okay. So we know it's some type of linear relationship, okay? Because it is going up. It's going up, which is true. All right. it says A, the cells of the compact disc, okay, and this is the cells of the compact disc, and batteries are positively correlated, and the graph implies causation. All right, so look, it is positively correlated, but the graph doesn't imply that it's a direct cause because um, the slope is not constant. Okay, since the slope is not the same every single time, it's not directly the cause of it. The number of packs of batteries sold is not directly affected to how many CDs are sold. It's just not. Here it says the sales of the compact disc and batteries negatively. It's not negative. The line's not going down. This is not true either. The sales of the compact disc and batteries are positively correlated. That's true, it is. But it does not imply that it's causation. That's the best answer. It doesn't imply this is it's a direct effect. If you'll know it's a direct effect when it's going up by the same amount every single time. Okay, if it goes up by the same amount almost every single time, then it's a direct correlation. Okay, all right, and that means it's causation. So I forgot what letter choice is that. That's C. So for number 9 on your paper, put C and move on to number 10. Number 10, it says students were asked how many minutes they spent doing homework during 1 week. The table shows the recorded times um, and their test scores at the end of the week. Okay. All right, so here we go. It says the correlation of the line of best fit for the data, and they give you the correlation. They tell you that R is 0.81. Okay, so what does that mean? We know off gate it's a positive number, so we know it's a positive correlation. We know that. We also know that it's strong because it's close to positive 1. All right, so let's read the answer choices and let's try to pick the best answer. The correlation coefficient indicates a strong correlation. That's true, which means that spending more time on homework causes higher test scores. Mm, um, yes and no, right? Okay, causes higher test scores. It can. Okay, is it direct? So this right here causes. Let's be cautious of that word. So this is a possible answer, okay? Is it the best answer? We don't know. It says the correlation coefficient, okay, indicates there's no, that it doesn't indicate that, okay? It doesn't indicate that, all right? So the closer it is to 0 means that it's a no correlation, and this is very strong. So this is not an answer. The correlation coefficient indicates a strong correlation. Yes, but it does not mean that spending more time on homework causes higher test scores. This is a better answer because they're using the word cause. If they would have said likely, the more the more time that you spend on homework, the more your test scores will go up. Yeah, that could have been a possible answer, but the fact that they're saying that it causes it, not always true. So this is the better answer than A because it does not mean that it's causing it that. So this is a better answer. The correlation indicates no. So C is the better answer here. Okay? Because it's not causation. Okay? It's not a direct cause of it. It helps, but it's not a direct cause. 11. Daryl has determined that the linear regress model for the data set, this is the linear regress model. Okay. Notice a couple things. The slope here is negative. Okay, and the y-intercept. What is the approximate value of the residual? So we got to find the residual. Remember, for 11, let me write down number 10. The answer to number 10 is C. Okay. So let's write 11. Remember, for number 11, let's do the residual. Okay. So the formula for residual, write this down, is your actual y value, actual y, minus the predicted y. Okay? All right, so let's look at the actual y value. Look, you see right here? This is the value that they give you. This is the y value they give you. So your actual y value is 978. That's your actual. Minus what's the predicted. So in order to find the predicted, you substitute 200 in the place of x to see what the y is, okay? So you got y is equal to a negative 1.98 times 200 is the x value plus 1,347. Okay, see what this predicted is going to be. So let's type that in. That's negative 1.98 times 200 plus 1,347. Okay? And so that's what that gives you as the predicted 951. So let's put 951 here. Okay? So the predicted is a little lower. So now to find the residual, again, you're going to subtract these amounts. So that's going to be 978 minus 951. And so your residual is 27. That's your residual. So the answer for residual is 27. Okay? So that answer choice is B. Okay? That is number 11. All right, number 12. Number 12, it says, which equation does not represent a function? Okay? A function is where your x values repeat. If the x values repeat, is where your x values do not repeat. If the x values repeat, it's not a function. So we're looking for where the x values repeat. So this is linear. If we put this in y equals mx plus b, this is linear. Look, this one right here, all the x values are 12. Every single last, if I was to graph this, x is equal to 12, I find 12 on the x-axis. Maybe this is 12 right here on the x-axis. And I draw a line through it. All of these ordered pairs would have the same x value of 12. All of them, okay? So this is the one that's not a function because all of these x values repeat. All of them are the same on this line. To graph this, if you forgot, you find 3, 1, 2, 3 on the y-axis and draw a line through it. Okay? That's how you graph y is equal to 3. All right, let's look at, this is number, pause real quickly. Okay, so number 12 is C. Okay, number 12 is C, which is x is equal to 12. Okay, this is the only one that's not a function. Okay, anytime you see x is equal to as an equation, that's not a function because it is a vertical line. It fails the vertical line test. Okay, all right, let's keep going. Turn on the back. 13. Okay. All right, so number 13 says, these are my points that are on this line. Okay, and it's asking, what is the y-intercept? So look, all you need to do to figure out what the y-intercept is of these points is to do the equation. And you can do the equation y equals mx plus b. You can do lean reg in the calculator. Linear regress. Okay, I'm abbreviating. So let's clear second. Oops, sorry, y'all. Second plus 712. And let's go to stat, edit. And let's type these ordered pairs in the calculator. So my first ordered pair is -8 and 4. Put the 4 over here. My second ordered pair is -6 and 8. Put the 8 over here. So now you got these two ordered pairs in the calculator. Make sure you type them in right. So now you go stat, calc, go down to lean reg so you can get the equation for this, and look. Press enter because I don't need to graph it or use a table. I just want to know what the y-intercept is. So this is my slope, and B, my y-intercept is 20. So here, my y-intercept is 20. So number 13B is 20, or my y-intercept is 20. So how do I write that as an ordered pair? That's 0, 20. Okay, that's where the line crosses the y-axis. Anytime the line crosses the y-axis, your x is always going to be 0. Okay, so the answer choice there is going to be B. B is your answer for 13. All right. 14. The table below shows the number of hours 7 students studied for math tests. 1, 2, 3, 4, 5, 6, 7 students. Okay. These are the hours. This is the grade. All right. So now it says, how does Amanda's test score compare to the score predicted using, again, line of best fit? That means we need to write an equation in y equals mx plus b. So again, we're going to use a linear regress. It's in the calculator. Clear your calculator. Second plus 712. Okay? All right. So we're going to use the table values for this. So let's type in our, this is x, this is y. Let's type in x first. 2, 1.75, 2, 3, 3.5, 3.5, and 2.25. Okay? Excuse me. Y, we got 84, 86, 88, 94, 95, 93, and 89. Okay? All right? Make sure they're right. Now we're going to do lean reg. So stat, calc, go down to lean reg. Now, for this one, I need to use, you see how it says you got to find the predicted amount, or you're looking for something. So that means I'm going to go back to doing second 1, comma, second 2, comma, vars. Y vars, and enter 3 times. I'm doing that so that the equation automatically goes here under y equals. And I can use my function. I can create a table from that. Why am I creating a table? Because look at what I have to do. So I'm going to use a line of best fit. It says, how does Amanda's test scores compare to the predicted? Okay, so this is, of course, the actual. This is what's given. How does it compare to the predicted? Okay, so we're looking for the predicted, but for which one? Amanda, right? So let's go down to Amanda. This is the predicted score that we're looking for, Amanda's predicted score. Okay, so we're looking for Amanda's predicted score. This is her actual. What is her predicted? So we use a line of best fit. So this is our x value. So we're going to type in 3.5 for x to see what the predicted is going to be. And the predicted is going to be the same for Patrick too, okay? All right, so we go to the table. See, we need to type in 3.5 and not just 3 or 4. So go to table set, and we're going to do X. Again, we're going to switch from auto to X. Okay? And we are going to go back to table, and I'm going to type in the 3.5. So 3.5. Okay, and that gives us 94 point, see, 94.674. Okay, so now about, it says, so now what is it telling us? Is it 5 points lower? So let's subtract the C, okay? We got 93 minus 94 point, what's that? 674. All right, so look, it is the, let's see, it's her actual lower. So this is her actual. Her actual is lower. But how much lower is it? It's 1.6, okay? So it's not 5, so this is not right. This is not right. 2. It's 2 points lower. That's about 2 points, okay? So this, is it 2 points lower? Yes. 2 points higher? No, it's 2 points lower. So it says 2 points lower, score. Let me see, let's say 2 points lower than the predicted. Yes, it's about 2 points lower than the predicted. Okay, so C is going to be your answer for 14. Excuse me. 15. 15. Leonardo, or Leonard, sorry, is studying the relationship between fuel efficiency in miles per gallon, Y, and the speed in miles per hour of a car. He collected 8 different speeds and found a linear model. This is the line of best fit here. All right, this is the starting amount, and this is the slope. Oh, the slope is positive. So we know that this is a positive correlation because the slope M here is positive point. That's something to look at, okay? Because it's asking you to analyze. All right, so now they graphed the residuals. So it's not done like a straight line. What they did was they graphed, after they did the predicted amounts, they graphed that part of it. So this is basically just telling you how far the lines are, how far your actual is away from the predicted. So look, this point down here is saying this person amount is less, sorry, this person's amount is less than, okay, this right here, I said person, but that means that this number is lower than the actual number. So that means the predicted amount, or the actual, is lower than the predicted. This means that the actual is higher. If it's above the line, the actual is higher. If it's below the line, the actual is lower. So look, in this case, the actual is above the line, 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 above the line. So all of these actual amounts are above the predicted, okay, is what that's saying. All right, so now let's look at our answer choices. There is a negative. No, it's not a negative relationship because look, the slope is positive. So this is not a negative relationship. It's actually a positive one because M is a positive number. This is a positive linear relationship, okay, between, and it is a positive, okay, it's a positive. That's given here. But look, they said using the residual. We didn't have to use the residual to know that it was positive. So even though it's the right answer, we didn't use the residual plot to figure that out. So this is an answer, but we didn't use the residual plot to figure out that answer. Here it's saying that it's nonlinear relationship. We know it's a nonlinear relationship because most of the points, the line of best fit, when you have a good line of best fit, that means you have almost the same amount of numbers above the line as you do below. Notice that you have more numbers that are above than below. So this is really not a good line of best fit for this data, which just tells you that it's not linear at all. okay? Because they couldn't even really find a good line of best fit that was in the middle. So this is telling you right here, since most of your points are above the line and it's not the same amount on top as it is on the bottom of the line, then it's really probably a nonlinear relationship. It's way off, okay? So C is going to be your answer here. So 15 is going to be C. I had a tickle in my throat. All right. So that one is C. Okay, so now we're on the last ones. Number 16, it says, which one of these points is on the line? Okay, look. The easiest way to do this without plugging these in, this is X, this is Y, this is X, this is Y, this is X, this is Y. We did this many times. You substitute the Y in, you substitute X and Y. If both sides are equal, it's on the line. If both sides are not equal, it's not. Another easy way to do is just to type the equation in. I'm going to put the fraction 3/4, close the parentheses, X minus 2. So now I'm going to look at the function table. Before I do that, I'm going to keep it on X. I already had it on X. And now I'm going to type my X values in. I have X value -10. -10 did not give me -10. So this is not it. Type in -8. Okay, this one gave me -8. So that's good. -6. That didn't give me, this gave me -6, so no. And -4. That gave me -5, so no. So my answer here is going to be B. So 16 is B. Okay, 17. We are doing line Q passes through these 2 points, okay? What is the equation for the line that goes through perpendicular? That which line is perpendicular to that? So perpendicular means that the slopes are opposite reciprocal. So I need to find the slope of this first, okay? So let's find the slope. 17. We're using m is equal to y2 minus y1 over x2 minus x1. Okay, so this is x1, y1, x2, y2. So it's going to be 6 minus 6 on the top. And it's going to be 0 minus 4 on the bottom. So this is 0 on the top and -4. So the slope here is going to be 0. So if the slope is 0, the opposite reciprocal slope of a line that's flat or 0 is undefined. So if the slope of the other line is undefined, the only equation where the slope could be vertical or undefined is where is for x is equal to. So this is easy. So look, this is my x, this is my y. So in order for it to go through this point, x has to be equal to a -2. So the equation is x is equal to -2. A tickle in my throat. Okay, so the last one, I need you to do the last one. You can do that one on your own. It's a linear regress there. So you're going to type these in as your x, this in as your y. Okay, this is your x, this is your y. Okay, and then of course Fn, that's the same as saying y is equal to, y is equal to, y is equal to, y is equal to. And choose which one of these is the equation. Don't forget, when you do linear regress, clear your calculator. 2 plus 7, 1, 2. Go to stat, edit, type in L1 here, L2 here, then go to stat, calc, lean reg, press enter, and it'll give you one of these equations. Okay? All right. All right. Have a great day. Sorry, I had a tickle in my throat, y'all.